Okay, students. So, hello, and I am taking out some of the questions for metals and non-metals for the revision purpose. Okay, so what is the first question asking here? Let's see. The first question is asking here which property of metal enables them to be drawn into wires. Okay, so which property of metal enables them to be drawn into wires? The property is known as the ductility. Okay, so the ductility is the property. Ductility is the property which enables them to be drawn into wire. What does ductility shows? The ductility shows the tensile strength. Okay, tensile strength of a metal. How much it can be easily, how much the tensile strength or how much tension it can bear easily. Okay, so as we can see here that the metals which are more ductile are gold, copper, silver, okay, etc., which can be easily drawn into wires. Okay, gold, copper, silver, generally they can be easily drawn into wires, and they are highly ductile due to their high tensile strength, Okay, next question he is asking here that name two most malleable metals. Okay, so the two most malleable metals are gold and silver. Okay, gold and silver. The two most malleable metals are gold and silver. You have heard about the gold foils. Okay, gold foils or silver foils, which is generally used in sweets. Okay, which is generally used in sweets for sweets coating. In our India we use them for sweet coating. Okay, in Hindi we call it as chandi ka work. Okay, chandi ka work, we generally see them in on the sweets. Okay, so these foils are having the thinness which is very lower than that of our hairs also. Okay, they are very thin. Okay, the thinness is that much smaller that they are very much thinner than our hairs also. Okay, so this property of being hammered into very thin sheets is generally with the gold and silver. Okay, is generally with the gold and silver. They can be easily beaten to very thin sheets. Okay, next question here is asking that name a metal which is preserved in kerosene and explain why. Okay, so the metal which is preserved in kerosene is sodium. Okay, it is sodium. What is the reason behind it? Sodium is highly reactive with air and water. Hence they are preserved in kerosene. In kerosene, a yellow colored layer for oxidation of sodium is been formed, which protects it from reacting. Okay, so when it is kept in kerosene, a yellow colored layer of oxidation of sodium is been formed there. Okay, due to this they are been protected from the reaction with the air and water there. Okay, next, which non-metal is lustrous? Next question here is asking that which non-metal is lustrous. Okay, so the non-metal which is lustrous is iodine. Okay, iodine is a non-metal which is lustrous. Okay, it is having luster means it is having shiny surface. Okay, it is having shiny surface. It is one of the exception in case of non-metals. Okay, it is one of the exception in case of non-metals. It is having shiny natures. Okay, generally iodine is liquid. Iodine is liquid, but when iodine is converted to solid, then its solid structure is containing lustrous surface. Okay, lustrous surface, shiny surface. So hence iodine is a non-metal which is lustrous. It is an exception in case of non-metals. Okay, the next question here is asking that name the metals which melts when kept on palm. Okay, name the metals which melts on when it is kept on palm only. So gallium and cesium. are the metals which are having very low melting point, that if they are kept in palm only na, they will readily melt out there. Okay, they will readily melt out there. Next is the on which electrode do we get pure silver during electrolytic refining of metal. Okay, so silvers are having positive charge, so naturally they will be deposited on cathodes, will be deposited on the cathodes. Okay, they will be deposited on the cathodes, and hence the silver rod is made as cathode there in order to prepare the pure silver there. Next, why does calcium floats in water? Okay, why does calcium floats in water? So when calcium is dropped in water, hydrogen gas is formed which stick to the surface of the calcium. Okay, when calcium is dropped in water, then hydrogen gas is released out. And this hydrogen gas, this H2, sticks to the surface of calcium, and hence it starts to float. Okay, and hence it starts to float. Okay, so the calcium starts to float on the water due to the releasing of hydrogen gas from the water when reaction of calcium and water is taken place there, and then this hydrogen gas sticks to the surface of the calcium, and due to this reason they float on water, and due to this reason only they float on water due to formation of gas bubble there. Okay, Okay, the next question is asking here that with which metal pure gold is alloyed to form jewelries. So first thing I am explaining you here is that 24 karat gold, which is also known as pure gold, is very what we call it as have very low melting point. Okay, and it is very soft, has very low melting point, and is very soft. Okay, and is very soft. It is very soft. It can easily be molded by our hand only. With the heat of our hand only, it gets molded. Okay, it gets the shape of the jewelries or the other things gets distorted. Okay, due to our heat of hand only. Okay, due to its softness. Okay, 24 karat gold or the pure karat gold. Okay, or the pure gold. So in order to make the jewelries, okay, in order to make jewelries which are having different shapes and structure, and they are in order to increase its strength, it is alloyed with pure gold, is alloyed with silver, either silver or copper. Okay, either silver or copper, in order to make it hard, Okay, in order to make it hard, and hence then jewelries can be made out, and hence jewelries can be made. Now one question arises, what are alloys? So alloys are not the compounds. Okay, alloys are not the compounds, they are the mixture of solids. Okay, they are the mixture of solids. Here, when two or more metals are mixed together to increase their strength or melting point or boiling point or we can also say that to enhance their physical and chemical properties. Okay, to enhance their physical and chemical properties. So these are the alloys. When two or more metals are combined or not combined, they are mixed together. They are mixed together in order to increase or enhance their physical and chemical properties, different physical and chemical properties. Some of the alloys I can give you examples such as aluminium plus magnesium, duralumin. Okay, aluminium is very soft. Okay, it is very soft in generally, but when combined with magnesium, this softness gets removed out and it becomes hard. Okay, and it becomes hard. This duralumin is harder than that of the aluminium. Okay, is harder than that of the aluminium. Okay, it is hard. Okay, while aluminium was soft. So hence plus hardness, it is having very lightweight. Okay, it is very lightweighted. So due to this reason, they are used as aeroplane metal. They are also called as aeroplane metal. They are also called as aeroplane metal. We also call them as aeroplane metal. So this is also one example for alloy. One more example for alloy you can take here is galvanization of iron. Galvanization of iron. Okay, galvanization of iron. Here iron pipes are galvanized with nickel. Okay, iron pipes are galvanized with nickel, or a coating, a layering of nickel is been formed out on the iron in order to prevent rusting, of irons. Okay, so the iron pipes which are used for handling the waters, okay, they are been coated with nickel. Okay, they are been coated with nickel metal, which are less corrosive as comparison to that of the iron, and it protects the iron from being corroded by the by coming in contact with water, and hence the life of the iron pipe here increases. Okay, the life of the iron pipe here increases by galvanization process. Okay, by galvanization process. So here one more example we can take other than galvanization, that copper is mixed with zinc. Okay, copper is mixed with zinc to form brass. Okay, brass or bronze. Copper is mixed with zinc to form brass or bronze. I am not confirmed about this, but brass or bronze are formed it when copper and tin is also combined. Okay, so this kind of alloys are also formed out here. So this is also an alloy which is highly used in our daily life. Okay, copper, bronze, brass, bronze, all these things are highly used in our daily life. Okay, so these are also alloys. Okay, also one more alloy can be used here. We can call it as German silver. Okay, whose utensils are generally used in our houses. Okay, so it is also an alloy of aluminium only. Okay, it is also an alloy of aluminium only, and here aluminium is been alloyed with other metals in order to form the alloys. Okay, and to enhance the aluminium's property, Let's talk about the next question here. Which is saying that what are the reaction of metals according to the reactivity series. Okay, what are the reaction of metals according to the reactivity series? So if I am talking about the reactivity series, we know that the reactivity series is the arrangement of metals according to their reactive nature. Okay, so if we are taking out the reactivity series and their reactions, then we can say that, we can conclude here that potassium, sodium and calcium reacts with cold water only. Okay, with cold water. They does not require the heating or any other thing. They can easily react with the cold water only. Okay, they can easily react with the cold water only. But when we come to aluminium, iron and zinc, they only reacts with steam. Okay, they only reacts with steam. They cannot react with cold water. Okay, there no reaction is seen with the cold water here, so they only reacts with the steam. Okay, next in case of iron and tin, it reacts with hot water also. Okay, hot water also means it is not necessary that they react with only steam only, they can also react with hot water also. Okay, they can also react with hot water. So here it is showing that we are going down in the reactivity series. Okay, we are going down in the reactivity series. Next, lead, copper, silver, gold are the metals are not reactive to water, it means they are the lowest metals in the group. They are the lowest metals in the group. They generally don't react with the water. Okay, they generally don't react with the water. Next is the calcium and magnesium. Calcium and magnesium, due to their reaction with water, they float on water. Okay, they float on water. Due to their reaction with water, they float on water. Okay, they float on water. Next, we can discuss some of the properties. For metals reacting with acids. Okay, metal reacting with acids. So we know that when metals are reacted with acids, what happens here? The reaction of acids with metals forms out that metals are reacted with acids to form metal salts with hydrogen gas. Okay, with hydrogen gas. So we can take example here, iron reacting with 2HCl, it will form FeCl2 plus hydrogen gas. Okay, Mg plus 2HCl, it will form MgCl2, magnesium chloride plus hydrogen gas. Okay, Mg H2SO4, MgSO4, magnesium sulfate, which is a salt plus hydrogen gas. Okay, so this kind of reactions are generally seen when metals are reacted with acids. Okay, when metals are reacted with acids. So this was some of the important questions for metals and non-metals. We will discuss some of the more questions in the next sessions also for metals and non-metals. So thank you.